Hello, this is Charlene. In this video, we're going to be talking about mutually exclusive events. These are events that cannot occur simultaneously. If A and B are mutually exclusive events, then the probability of A or B is equal to the probability of A plus the probability of B. The second part over here is using a symbol in place of the word or. In place of the word or. So we can definitely think that the or can be replaced with this symbol. This symbol means union. Therefore, we can actually say this, the probability of A union B. So the probability of A union B. The probability of A union B is still equal to the probability of A plus the probability of B. Because like I said, this right here using the word or this part using the symbol are interchangeable. So we can also think about the fact that it says that we are adding. Here it has probability of the first thing plus the probability of the second thing. And over here it is also adding. So anytime we have the word or the symbol for or, the union symbol, we are going to add their probabilities together. So let's take a moment to just think more deeply about what it means to be mutually exclusive. So, is a cat equal to a dog? Well, no, it is not. A cat can never be a dog. So those two things are mutually exclusive because a cat cannot be a dog at the same time that it is a cat. So those two things are mutually exclusive. Can a number 7, can it ever be a number 8? No, they are never going to be the same at the same time. So those are also considered mutually exclusive events. Okay, we can find probabilities of mutually exclusive events. This tells us that we are randomly selecting one card from a 52 card deck, and they want us to find the probability of selecting a 7 or an 8. And of course, we can write that as the probability of 7 or 8. And again, we have to remember, what does it mean when we're finding the probability of one event or another event? Well, we remember that we are going to add the probabilities. So that means that I am going to rewrite this as the probability of pulling a 7 card out of the deck plus the probability of pulling an 8 out of the deck. Well, how do we find probabilities? Well, again, we go back to what we know about probabilities. It's a part out of a total or part out of a whole. So we need to figure out what is the 7 that is the part out of this deck of cards. Well, where are my 7s? My 7s are right here. So I got 7, 7, 7, 7. So I have 1, 2, 3, and 4 7s. So that is my part, 4. And how many total cards do I have in the deck? Well, it's a 52 card deck. That's normal and standard. So 4 out of 52. And then I'm going to add that to the probability of an 8. Well, where are my 8s? There's an 8, there's an 8, there's an 8, and there's an 8. So I also have 4 8s in my deck of 52 cards. So when I add those two probabilities together, I get 8 out of 52. And then I can reduce that. I can reduce that to 4 out of 26. And I can reduce that again. So that final reduction is going to be 2 out of 13. So the probability of selecting a 7 or an 8 out of a 52 card deck of cards is 2 out of 13. Our next problem wants us to find the probability of pulling a red 7 or a black 8 out of our deck of cards. Again, the word or implies that we are going to add the probabilities. So I can rewrite this as the probability of a red 7 plus the probability of a black 8. And again, we're finding parts out of wholes. So how many red 7s do I have? How many red 7s do I have? I have a red 7 here and a red 7 here. So that means that I actually have 2 red 7s out of a deck of cards that contains 52 cards, plus how many black 8s do I have? Let's see, black 8s, I've got one right there and one right there. So I also have 2 of these cards. So 2 out of a deck of 52 cards. So 2 50-seconds plus 2 50-seconds equals 4 out of 52. And then that reduces to 2 out of 26. And then we can reduce that one more time to 1 out of 13, or 1/13. So the probability of a red 7 or a black 8 is 1/13, or 1 out of 13. The next problem wants us to find the probability of pulling a 7 of hearts out of our deck or pulling an 8 of spades out of our deck. Again, we've got the word or, so we're going to add our probabilities. So that means that we can rewrite this as the probability of a 7 of hearts plus the probability of an 8 of spades. And let's remember, what does a spade looks like? It looks like that. Okay, so let's go find our part out of our total. So how many 7 of hearts do I have? Well, the hearts are that third suit, and there's a 7. So I only have one of those, one 7 of hearts out of 52 cards. And then I want to look for my 8 of spade. Well, the spades, that's this suit right here. And there's the 8. And again, I only have one of those. So that is going to be also 1 out of 52 cards. The probability of pulling an 8 of spades is 1 out of 52. I add those probabilities together. I get 2 out of 52. And that reduces to 1 out of 26. So the probability of drawing a 7 of hearts or an 8 of spades is 1 out of 26, or 1/26th probability. Okay, the last problem for this video says that a political discussion group consists of 30 Republicans, 25 Democrats, 8 Independents, and 4 members of the Green Party. If one person is randomly selected from the group, find the probability of selecting an independent or a Green Party member. So again, they're using the word or. So we remember that if we're using the word or, that means we're going to add our probabilities together. And that means I should be able to write my probability in this format: the probability of an independent or a Green Party member. Because we're using the word or in our probability, that means we're going to add the probabilities together. So that means we're going to find probabilities. That means we're going to find the part out of the total. Well, that means we need to know what the total is. So again, they told us that we had 30 Republicans, 25 Democrats, 8 Independents, and 4 Green Party members. And all of that adds up to a total in the discussion group of 67. So now I need to find my independent part. So my independent part is the 8. So 8 out of the 67 total, plus find my Green Party part. So my Green Party part is 4. So that's going to be 4 divided by 67. And that is going to add up to 8 plus 4 is 12 out of 67. So this means that the of probability of selecting an independent or a Green Party member is 12/67, or 12 out of 67. That is reduced. It will not reduce any further, so we are finished. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.